Take a quiet, deep breath. The oxygen you just inhaled was likely produced by ocean plankton thousands of miles away and carried right to you by global atmospheric currents. Kind of mind-blowing, right? Welcome to this explainer. Today we're taking a calm, structured look at the foundational systems that literally keep us alive. We hear the word environment thrown around constantly in the news, but we rarely pause to map out what it actually means on a biological, physical, and social level. So let's build a clear, interconnected picture of this whole thing, right from the ground up.
Here is our roadmap for today. 1. Defining our surroundings. 2. The 3 core components. 3. The 4 environmental segments. 4. What is environmental education? 5. A multidisciplinary approach. And 6. Why awareness matters today.
All right, let's jump right into Section 1, Defining Our Surroundings.
The word itself actually originates from the French term environner, which translates to encircle or to surround. You know, for us, the environment isn't just some pleasant backdrop of trees and oceans. It really represents the total, complex composite of conditions that dictate the very boundaries of life. It's the absolute sum of the air, soil, water, thermodynamics, and physical space that encircles us. The whole shebang. Everything an organism needs to execute its basic biological functions, from cellular respiration all the way to massive, large-scale migrations, is drawn entirely from this all-encompassing circle.
Moving on to Section 2, the 3 core components.
Think of the global ecosystem like a highly dynamic, 3-part flowchart. First up, we have the abiotic components. This is basically the physical theater, the non-living architecture made up of soil, water, and atmospheric gases. Second, we've got the biotic actors operating on that stage. This is the entire living realm: microscopic flora, massive fauna, and of course, us humans. But here's the catch. Neither the theater nor the actors can do a single thing without the third component: energy. Solar radiation from the sun, geothermal heat radiating from the Earth's core, and atomic energy. They fuel these relentless feedback loops between the living and the non-living. Every single interaction on Earth traces back to how energy flows through abiotic materials to sustain biotic life.
That brings us to Section 3, the 4 environmental segments.
To really understand this physical theater, we need to map out its 4 specific domains, starting with the sky above us. When you look at how this is structured, you see the atmosphere is far from just empty space. It's a highly organized, layered system defined by sharp shifts in altitude and temperature. Down in the troposphere, which is where our weather happens, the temperature actually drops as you climb. But notice the critical threshold just above it in the stratosphere, running from about 11 to 50 kilometers up. That is where O3, the ozone layer, acts as this active, dynamic chemical shield. It absorbs tissue-damaging ultraviolet radiation from the sun. Honestly, without this very specific chemical interaction happening miles above our heads, complex life on the surface just wouldn't be viable. Now let's consider the hydrosphere. We're always taught that Earth is 71% water, right? But 97% of it is ocean salt water. Of the tiny 3% that's actually fresh, look at how severely restricted its distribution is in this breakdown. 79% is locked away in polar ice caps and glaciers. Another 20% is trapped deep underground. That leaves exactly 1% of the Earth's total fresh water readily available in rivers and lakes for ecosystems and human use. To put that into perspective, if all the Earth's water fit into a single-gallon jug, the available fresh water that sustains all land-based life would equal barely a tablespoon. Pretty wild to think about.
Bringing it down to solid ground, we have the lithosphere. This is the structural foundation of our world, the outer solid mantle made up of complex minerals, organic matter, and soil. It's the ultimate storehouse of nutrients. But the final segment, the biosphere, is totally unique. It isn't a separate physical location at all. It's the fragile, dynamic intersection where life actually happens. Extending just 6 to 8 kilometers up into the sky and 8 to 10 kilometers down into the sea, the biosphere exists entirely at the mercy of the atmosphere, hydrosphere, and lithosphere working in precise unison. It really is just a razor-thin slice of habitability.
Next up is Section 4. What is environmental education?
So historically, humanity's limited needs allowed for a sort of primitive, natural harmony with these massive environmental systems. But as industrialization accelerated and population growth exploded, that balance shattered. We fundamentally altered the chemical makeup of our atmosphere and hydrosphere. This unchecked degradation forced a global awakening, which really crystallized during the 1972 Stockholm Conference. The international community realized that fixing this damage required a completely new educational paradigm. That momentum culminated in 1977 with the Tbilisi Declaration, which essentially formalized exactly how we need to teach societies to survive in a rapidly changing world.
The 1977 Tbilisi Conference laid out some foundational systemic guidelines. It established that ecological literacy can't just be a singular one-off high school biology class. It has to be continuous, stretching right from preschool through all stages of adult life. It must critically examine environmental issues across all scales, from your local water tables to huge international climate agreements. And most importantly, it has to equip learners to discover the real structural root causes of environmental problems. The goal is to move past just treating the symptoms and start addressing the core human behaviors driving the crises. It's all about cultivating a systems-based mindset, not just memorizing facts.
Which leads us perfectly into Section 5, a multidisciplinary approach.
Solving global ecological degradation requires a highly specific, interlocking map of human knowledge. It's like a giant puzzle. You can't address an ecosystem without botany and zoology deciphering the biotic interactions. You need physics and chemistry to map out the physical phenomena, like how pollutants disperse through the troposphere. But purely understanding the science isn't enough. We rely entirely on civil and chemical engineering to physically build pollution controls and innovative renewable technologies. And because human behavior is the actual engine of this degradation, sociology, economics, and law are absolutely crucial to reshape policies and human incentives. Every single discipline acts as a vital node in the flowchart of our survival.
And finally, Section 6, why awareness matters today.
Right now, these foundational systems we've just mapped out are buckling under severe modern pressures. The measurable threats compound on one another. Fast depleting forest resources are eliminating our carbon sinks, while rapid population booms increase demand. At the exact same time, expanding industrialization and highly unplanned urbanization push massive amounts of waste into that tiny, figurative tablespoon of available fresh water we talked about earlier. This isn't just about losing beautiful scenery, you know? Our quest for rapid economic development and a highly materialistic lifestyle has triggered a relentless exploitation of resources. It's a direct threat to the biological scaffolding keeping us and countless other species alive.
Which brings us to a powerful realization. Environmental education is education through environment, about environment, and for the environment. Legislation alone simply cannot save a society that lacks ecological literacy. No government mandate is going to succeed if the public doesn't understand the basic flowchart of the abiotic, biotic, and energy systems that govern their daily lives. We have to deeply understand that degrading our physical surroundings today practically guarantees systemic biological failure tomorrow.
So, as we wrap up this explainer, here's something to try. Take a moment to really think about how you interact with these systems. You're not just living on the Earth, you're an active, biological component deeply embedded within its biosphere. Every breath you take and every drop of water you drink ties you to these global segments. If our survival relies entirely on the precise chemical and physical balance of these systems, what is your specific daily role in maintaining that balance? Think critically about the interconnections we've mapped out today. Thank you so much for exploring.